Here I am going to introduce you inverse of a function. We know the function, the relation, one-to-one relation, many-to-one relation between x and y is a function. The relation starts from y and gives you a y. So input is x and output is y. Now inverse of a function is a function that reverses another function. So when input is x and output is y. Now inverse of a function is, we denote as f to the power of -1 to y gives the result of x. So f inverse of y is equal to x. No, don't mistake me, we don't pronounce it as, we do not pronounce it as f to the power of -1, though we write like that. We say it is a inverse, it is inverse of f. So let's not use the word to the power, don't think as a 1 over f. If we simply write as inverse. The notation looks like an exponent, but it's actually not an exponent. It looks like it's not an exponent. We say it is an inverse of f. The relation is here from y to x. The relation is here from y to x. So that is very, very important here in the case of an inverse of a function. Now, some important properties on inverse of a function. Inverse of a function is obtained by swapping the x and y values. Point number 2, domain becomes a range and a range becomes a domain. One-to-one relation becomes one-to-one relation, hence both function and its inverse are functions. Many-to-one relation becomes one-to-many, hence the inverse of the function is not a function. Many-to-one is a relation, is a function, but the inverse is not a function because it becomes one-to-many relation. The graphical meaning, let's look at the graphical meaning. We said swapping the values of x and y values. It implies that xy is a coordinate, xy will become yx. Yes, therefore it means the graph is reflected about the line y is equal to x. So we have two interpretations here. The inverse of a graph means swapping the values of x and y values. And number two, graphical meaning means is a reflection about the line y is equal to x. We represent f inverse. This is a notation that we use, f, and just like we write exponent and I write -1. But we don't read it as f to the power of -1. We read it as inverse of f. I'm repeating this fact. So let's understand the notation here. The notation here is f, the function, and on the, just like we write the power, we write -1, and we read it as inverse of f. And it is totally different from 1 over f. Don't assume that this is not f of x, this is also wrong. It's simply f inverse of x. This is how we write the notation of a function. How to determine the inverse of a function? It involves very two simple steps. Simple steps, but don't make it complicated. It is first step is I know my function here is my y is equal to f of x. This is the function. Now my first step to find the inverse, what I will do, I'll swap the values. Step number 1 is swap the values of x and y. Right? That is xy will become yx. That is my first step. Second step is make y the subject of the formula. Make y the subject of the formula. So it involves two steps here. First, swap the values, and then second step, make y the subject of the formula. That's how we find the inverse of a function. And let us take the example. Let us take the example of how to find the inverse of a straight line. Y is equal to say 2x plus 2. So this is a straight line, is a function, is a straight line, is a function, and how we are going to determine the inverse of this straight line. So we know f of x is equal to y. That's how we write it. This is the original function, which is equal to 2x plus 2. Now to find inverse, what was my first step? My first step is to, in this equation here, y is equal to 2x plus 2, I write it as x is equal to 2y plus 2. That's my first step, number one. Swap the values, right? I swap x and y. In the equation. Now there's my second step is to make y the subject of the formula. So what I do then, therefore it is x minus 2 is equal to 2y, or in other words, half 1 over 2x minus 2 over 2 is equal to y. In conclusion, I can write y is equal to 1 over 2x minus 1. So this is my f inverse. And I write as f inverse of x is equal to half x minus 1. So my function here is 2x plus 2. Its inverse is half x minus 1. Yes. Here my function is 2x plus 2 and it's a straight line on the Cartesian plane. And now let's see what will happen to the graph when it's reflected over the line. This is my line, y is equal to x. So inverse, in other words, is the inverse, and I will get the inverse graph. So this graph that you see here, this is my inverse graph. Yeah, half x minus 1. So it's a reflection over the line y is equal to x. It's interesting to see now the x-intercept, the original function is minus 1, and that will become the y-intercept minus 1. The y-intercept, the original function, will become the x-intercept of the inverse function. Now let's see the case of where the function is a parabola, the quadratic x square minus 1. Take some example, x square minus 4. And I draw this figure, on the Cartesian coordinates, and I will get this graph, parabola graph, x square minus 4. Now let's see what will happen if I reflect on the line y is equal to x. So I'm going to find the inverse. I'm going to find the inverse of this function. So how I find the inverse? My first step is, my original equation here is y is equal to x squared minus 4. Now I have to find the inverse. That means I'm going to find f inverse of x. That's what I'm going to find. So my first step is, I rewrite the equation x is equal to y squared minus 4. Right? And then what will I do? I have to make y the subject of the form. That means x plus 4 is equal to y squared, and therefore y is equal to plus or minus square root of x plus 4. So this is my equation f inverse. So f inverse of x is given by plus or minus square root of x plus 4. Now let us see what will happen if I reflect over the line y is equal to x. And it will give me a parabola here. Now if I apply the vertical line test, you can see that if I apply the vertical line test, it intersects at It intersects at 2 points, therefore, the F inverse is not a function. Hence, my statement that this F inverse plus or minus is not a function. Therefore, this statement is inappropriate. Let's look. We have seen that the inverse of a parabola function is not a function. This is not a function. Now, our purpose is to make the inverse a function. For that, what we will do, we'll restrict the original function. So here we are going to now to learn more about the restricted function. A restriction of a domain, restriction of a function means I am having a smaller domain and I get a new function. So here, let's look at the domain of the functions of f, the original function. The original function has a domain. The original function has a domain of x element of R. That means for all x values, and a range was y greater than or equal to -4. All the values above the turning point. And I have the turning point here as 0, -4. So these are the properties of the original function f of x square minus 4. Now I am going to restrict the original function so that the inverse becomes a function. That's what we are going to do now. Restrict the functions. I am making a domain. I am restricting the domain. I am making the smaller domain. Now I am going to restrict the domain x less than or equal to 0. This 0 actually comes from the 0 x coordinate of the turning point. So I restrict up to the turning point, first half of the turning point. In other words, you can look at the parabola as two equal halves cut by the axis of symmetry at the turning point. So now here I'm going to restrict the domain x less than 0. Then the graph will be up to this half from to the x less than or equal to 0. That will make graph. And the range is definitely, my range will be, there will be no change in the range. Range will be, y will be greater than or equal to -4. So this is my restricted graph now. This is my restricted graph. I'm purposefully not drawing on another Cartesian plane so that you understand that I am on the same graph. I'm restricted the graph. You can see this is my graph here. dark colored so that we know that we are speaking about this is my new graph, new function. Function itself is f of x. There's no change in the function. F of x is equal to x square minus 4. What has changed? Change is the domain, and there's no change in the range here. Now I'm going to restrict this graph. Now what about the inverse? Inverse will be, as you can see, y is equal to, I cannot write plus or minus root of x because my inverse now will become the range. Domain now will become the range in the case of the inverse, and the range will become the domain in the case of the inverse. So inverse, if I write here root of x, that means x is less than or equal to 0. But when it becomes a range here, the range of f inverse is supposed to be y less than or equal to 0. That means this has to be negative. So y is equal to negative root of x, and my domain will be x greater than or equal to negative 4. That means my graph will be, if I draw the inverse of this graph, my graph will be, this is my graph of f inverse. Now I am going to restrict the domain for x greater than or equal to 0. X greater than or equal to 0. So if I drew the graph, this is going to be my x greater than or equal to 0. The other half of the parabola, x greater than or equal to 0. My function remains the same. My original function is x square minus 4, but the domain is now restricted to x greater than or equal to 0. And what will happen to the range? Range still remains at y greater than or equal to negative 4. Now in the case of f inverse, now if I take the f inverse now, in order to make it a function, I restricted the graph. So now f inverse is y is equal to root x. Now let's see, it should be plus x or minus x. X is greater than or equal to 0. Therefore my range of the f inverse must be greater than, y must be greater than or equal to 0. Therefore y must be positive. Therefore I'll write y is equal to plus root x. Therefore plus root x. And what about my domain? My domain here, my original function or range was y is greater than or equal to negative 4. Therefore my domain will be x greater than or equal to negative 4. So let's look at now. X is greater than 0 of the f. Therefore f inverse range will be y greater than or equal to 0. In the case of range or f of x, range was y greater than or equal to 0. In the case of f inverse, range will be y greater than or equal to, domain will be x greater than or equal to negative 4. So if I draw this graph here, it will be like this. This is how the graph will look like for the inverse, so that the quadratic function, the inverse is a function. Now we have seen the inverse of a function is swapping the values of x and y. That means we can swap the values of x and y, means xy will become yx. It means the graph is a reflection about the line y is equal to x. The reflection about the y is equal to x is same as inverse of a function. How do we determine the inverse of a function? First we write y is equal to f of x. Then we write, the step is swap the values of x and y, and then make y the subject of the formula. Yes, we have seen the straight line function y is equal to ax plus b. To find the inverse, we'll first swap the values of x and y, and then make y the subject of the formula to find the f inverse of a straight line. In the case of a quadratic, to make f inverse a function, we restrict the domain so that the inverse becomes a function. We have seen that. Then, in the case of the hyperbola, we are not discussing about the inverse of a hyperbola, but you must remember the in hyperbola also we also restrict the domain x not equal to negative p is a restriction of the domain to make as a function. In the case of the exponential function, the inverse of an exponential function, we'll introduce a new concept in mathematics which is called logarithm, and we'll discuss a logarithmic function in the next video.